The topic that I'll be explaining today is the empirical and molecular formula. What is it? The empirical formula shows the lowest whole number ratio of elements present in a compound. The molecular formula shows how many atoms of each element are present in a molecule of the compound. So basically, the empirical formula is a reduced version of the molecular formula. Some examples are glucose. For glucose, the molecular formula is C6H12O6, and the empirical formula is CH2O. That's the reduced version of the molecular formula. For water, though, the molecular formula is H2O, while the empirical formula is also H2O, because you can't reduce it any further. Steps on how to get the empirical formula. First, you need to assume that there are 100 grams of the sample. Then you convert all percentages to a mass in grams. After that, you use the periodic table to find the molar mass to find the moles of each element. Step number 4 is to divide the moles of each element by the smallest of these to get a mole ratio. If the numbers in the mole ratio are whole numbers, then you could directly convert this to the empirical formula. If the numbers of the mole ratio are not whole numbers, then you need to find the fixed numbers to multiply each of these by until the mole ratio, until there's whole numbers for the mole ratio. Practice. If carbon and hydrogen are present in a compound in a ratio of 1 to 2, the empirical formula of the compound is CH2. If sodium, oxygen, and hydrogen were in a ratio of 3 to 1 to 2, what is the empirical formula? You're right. Na3OH2. This is a more tricky one. If carbon and hydrogen are in a ratio of 3 to 6, what is the empirical formula? Right again. CH2. Here's an example. A compound containing 47.25% copper and 52.75% chlorine with a molar mass of 268.9 grams. Find the empirical formula. So the first step is to assume that there's 100 grams of the sample. Then you have to convert the percentages to mass. That's an easy conversion. You just divide by 100 and multiply by 100, and you change the percentage to grams. So for copper, you have 47.25 grams, and chlorine, you have 52.75 grams. The third step is to find the moles of each element. You could do that by finding the molar mass using the periodic table and dividing the grams by the molar mass. For copper, we end up getting 0.7435 moles of copper, and for chlorine, 1.488 moles of chlorine. Next, you divide the moles of each by the smallest number to get the mole ratio. The smallest of these two is copper of 0.7435. So you divide both numbers by that, and for copper you end up with 1 and chlorine you end up with 2. So the ratio is 1 to 2. Since these are whole numbers, you can directly convert it to the empirical formula, which is CuCl2. CuCl2. Solving for molecular formula. So the first step is to find the molar mass of the empirical formula by using the periodic table. Next, you divide the mass given in the equation by the molar mass found earlier. After that, you multiply the entire empirical formula by this number, and you get the molecular formula. This is an example using the same data from before. From before, in the equation, the given mass was 268.9. So you take that mass and divide it by the molar mass of the empirical formula. You could find that by using the periodic table, which you'll eventually get 134.45 grams per mole. So you divide 268.9 68.9 by 134.45, and you get 2. Next, you multiply the entire empirical formula CuCl2 by 2 and end up getting Cu2HCl4, which is the molecular formula.